Welcome to episode 05 of CipherVibe's end-to-end cloud security architecture course. Perimeter protection reduces exposure where public traffic meets cloud applications and services. The modern edge is distributed across DNS, CDN, DDoS defense, web application filtering, and controlled ingress. We will connect its purpose, design boundaries, implementation path, failure modes, and evidence of effectiveness. Every cloud security layer relies on the ones around it. It complements, not replaces, identity, workload hardening, API security, and segmentation. An edge decision should route only intentional traffic to a protected origin while leaving evidence for detection and incident response. Treat the architecture as a chain. A trusted identity requests an action, a policy makes a decision, a workload or data service enforces it, and telemetry records enough context to investigate later. The first building block is define the approved public surface. Begin with an inventory of public names, addresses, APIs, load balancers, CDN distributions, and origin services. Define which applications may be public and ensure origins accept traffic only through the intended edge path rather than directly from the internet. The second building block is use layered edge enforcement. DDoS services absorb volumetric attacks, CDNs reduce origin load, WFs inspect HTTP behavior, and network firewalls govern broader protocol flows. Tune each for the application it protects and avoid a rule set that blocks real users without a tested exception process. The third building block is protect the origin and management plane. Close origin bypass paths by using private connectivity, security group restrictions, authenticated origin requests, and separate administration routes. Restrict management interfaces, protect DNS changes, and require review for edge policy updates because a small misconfiguration can expose or interrupt many services. The fourth building block is observe abusive patterns. Collect request, firewall, WF, DNS, and origin logs with enough fields to understand the client path, rule action, application endpoint, and response. Tune rate limits and bot controls from observed behavior, and retain a safe way to test changes before deployment. Use this reference pattern. Begin with an explicit policy that describes the permitted outcome. Enforce that policy at the closest reliable control point. Route decision and activity evidence to protected storage. Then give an accountable team a tested path to review exceptions, correct drift, and respond to violations. A reference edge places a managed public front door in front of each approved service, binds the origin to that front door, applies observed WF and rate policies, and centralizes request evidence. Implement this layer in a sequence that preserves evidence and limits blast radius. First, inventory all public endpoints and their owners. Second, route approved web traffic through CDN and DDoS protection. Third, restrict origin so edge bypass is impossible. Fourth, apply WF, bot, and rate rules in monitor mode before enforcement. Fifth, centralize edge and origin telemetry with response ownership. Prefer pilots with a named owner and rollback plan over an unmeasured organization-wide switch. The best rollout is one where a normal workflow succeeds, an unsafe path fails closed, and the team can explain the decision from logs rather than intuition. Security architecture fails most often through assumptions, not dramatic movie-style attacks. First, assuming a WF makes an insecure application safe. Second, leaving origin addresses publicly reachable. Third, blocking legitimate traffic without an owner or exception process. Fourth, treating DNS and CDN configuration as non-security changes. A configuration screen is not assurance. Collect evidence that the intended control applies to the correct scope and that violations become visible. First, compare external discovery with the approved public service inventory. Second, test allowed traffic, blocked attack-like patterns, rate limits, and origin bypass denial. Third, measure WF false positives and DDoS response readiness. Fourth, review edge policy changes and protected log retention. Test both normal activity and a safe negative case in an authorized environment. Record the expected decision, the evidence location, the owner who reviews exceptions, and the rollback method. Repeat after platform changes, new integrations, or major shifts in business use. For a practical exercise, design the edge path for a fictional public API and its private application origin, including the decision records you would retain. Use synthetic information or an environment you own or are explicitly authorized to administer. Deliver a one-page diagram, a concise control statement, a list of expected audit events, and one test for an allowed path plus one test for a denied path. This artifact is more valuable than a screenshot because it explains the reasoning behind the configuration. Before scaling this layer, ask 5 review questions. Which assets, identities, or environments are in scope? Who owns the desired state and exception decisions? Which enforcement point can reliably apply the rule? Which records prove the decision and retain enough context for an investigation? And how can the organization revoke access, contain impact, or roll back safely when a control fails? Good architecture makes these answers explicit and testable. The key lesson is that perimeter protection becomes dependable only when design, policy, enforcement, evidence, and ownership move together. Document the decisions you make, remove permissions and exposure that do not support a real requirement, and rehearse the paths that matter before an incident forces the lesson. Continue through the next episode to connect this control layer to the rest of the CipherVibe cloud security architecture.